In this lesson we're going to talk about how to use rational exponents. So you may have noticed that radicals are quite clumsy to work with. They're not very friendly at all, they're kind of clunky, and exponents are better to use, but how can we write roots as exponents? Well, the answer is fractional or rational exponents. So we're going to take our radicals and make exponents out of them, and our exponents will be fractions. Here's how it works. The denominator of our exponent will be the index of the radical. So we're all familiar with the radicals that have the index in the little crook. So this number that is the index will always be the denominator of your radical. Could not be simpler. The index becomes the denominator. So the third root of x can also be written as x to the 1/3. The seventh root of x can also be written as x to the 1/7. The square root of 20 can also be written as 20 to the 1/2. Because remember, if we're using a square root, we don't write the index, but we assume the index equals 2. So we knew that was square root. So we don't write the 2, but we know it's there. So the denominator of our exponent is 2. And we can also do this when we have powers. So in this case, I have the fourth root of x to the 3rd. Well, this third power becomes the top of my exponent, and always the index becomes the denominator. So here is y squared, fifth root of y squared, so I can change that to y to the 2/5. And the square root of m to the 5th would be m to the 5/2. So I hope you're seeing the pattern here, that the exponent becomes the top and the index becomes the denominator every single time. So now we're going to evaluate some rational exponents, and your calculator will do this, but it's also good to be able to do it in your head. And you'll be able to do more in your head than you think, probably faster in some cases than you could reach for the calculator. So these problems use powers and roots that you should already know. And like I said, you can use your calculator. Before we get started, let me give you some helpful numbers just in case you've forgotten any of these. Here are all our powers of 2, a few powers of 3, powers of 4, powers of 5, and powers of 6, and a couple of powers of 7. So, you know, you've always got your calculator to help you out with these, but you should at least know the first 5 powers of 2, and you probably all know the first 4 powers of 3. And the rest of these, the more you see them, the more they stick with you. But if you at least are familiar with them, it makes the problems a lot easier. Okay, to evaluate with rational exponents, we do 2 steps. Root first, then power. In other words, we handle the denominator of the exponent first, then the top number. It could be done in either order actually, but it's just easier because this way the root, if you do the root first, it keeps the number small. If you do the power first, the number is going to get huge. Here is our first example. 16 to the 3/4 power. Remember I said do the root first, then the power. So ask yourself, what is the 4th root of 16? And the answer is 2. So now we have 2 to the 3rd. The 4th root of 16 is 2, and all that's left of our exponent now is the 3 because we've used up the bottom part. And 2 to the 3rd is 8. And let's see a few more of those. 27 to the 2/3. Well, remember, first do the denominator. So what is the 3rd root of 27? Well, the cube root of 27 is 3. So what I'm really after here is 3 to the second power. And 3 to the second power is 9. One more. Let's do 32 to the 2/5. So the 5th root of 32 is 2. And then 2 to the second power is 4. I hope that you will take these and try several of them in the homework and get really good at this. This is a nice skill to have. Now remember that negative exponents cause a flip, or in other words, a reciprocal. So don't let it bother you if you see a negative exponent, because you know that all that does is flip the base over. Here I've got 64 to the negative 1/3. So I can go ahead and do the third root of 64 is 4, but I know that the negative is going to cause it to flip over. And here's another one, 8 to the negative 5/3. So the third root of 8 is 2, and then we're going to have 2 to the 5th, but the negative is going to cause it to flip over. See? So I did the third root of 8 is 2. That gives me my new base. So now I've got 2 to the 5th, but it's flipped over into the denominator because of that negative there. And so it's 1 over 32. And so here are several of these for us to practice on. We'll just go through them one at a time. Okay. The square root of 64 would be 8. The third root of 125 would be 5. The fourth root of 16, now hold on, make sure what we're doing the fourth root of. In this case, we're doing the fourth root of 16, not negative 16, because remember, the exponent can only apply to what it is next to. And in this case, there are no parentheses, so the exponent is next to the number. So we say the fourth root of 16 is 2, but that negative sitting there is going to make it negative 2. Okay, here is the third root of negative 27. So I'm looking for something that when I raise it to the third power, it gives me negative 27. Well, that would need to be negative 3. Okay, here I'm looking for the square root of negative 25, or something that when I raise it to the second power, I get a negative 25. And of course that number is not real, because anything to the second power would be a positive, not a negative. Okay, here is 64 to the negative 1/2. The square root of 64 is 8, but the negative exponent is going to cause it to be a reciprocal of 8. And now let's do these. The square root of 9 is 3. So at first I do the square root. The square root of 9 is 3. And then I've got 3 to the third power is 27. Okay, now on 27 to the 4/3, the denominator is 3. So I'm looking for the cube root of 27. That's 3. Now I have to do 3 to the 4th power. And, well, if I do 3 times 3 times 3 times 3, gives me 81. Alright, the 5th root of 32 would be 2. And I've got a negative here. So the negative is going to cause it to flip over. The 5th root of 32 is 2, so it's going to be 2 to the 3rd. Now I have to work out 2 to the 3rd is 8, but it's in the denominator, so I have 1 over 8. Alright, last one. The cube root of 64 is 4. And because of this negative exponent, I have it flipped over. So it's going to be 4. The cube root of 64 is 4. So it's going to be 4 to the second power. So that's going to be 1 over 16. Okay, I did promise you that your calculator would do this as well as you could do it in your head. And so now, even though I can't show you the calculator, I can at least show you the button that you're probably looking for. And you are going to want to use the power key, which looks like a little up arrow, or some people call it a hat or a caret. And so this is the one you want. It's the power key. And the power key understands that everything that comes after that key is the exponent. So if I want to do, for example, 81 to the 3/4, what I have to do is put the base in first, and then hit the power key. And then, because 3/4 is a quotient, and it has two numbers, so if I just put the 3 divided by 4 here, the calculator will think that the exponent is 3. And then it will divide the whole answer so far by 4. That's not what we want. We want 3 divided by 4 to be the exponent, so use your parentheses. So you're going to have 81, caret key, parentheses, 3/4, and then the equal key. Now the parentheses are super important. Without them, remember, the calculator only thinks that 3 is the exponent and not the whole fraction. So the parentheses tell the calculator what is included in the exponent. Now, if you ever have negative exponents, make sure you use the negative key, which is down at the bottom row of your calculator, not the minus key over on the right side by the plus, but the negative key. And what you need to do is get in the study plan and work some problems, or get in your textbook, work some problems in your head, mentally, and also on the calculator to make sure that you know how to work it. Test day is a really bad time to find out that you don't know how to use your calculator. So practice is the bottom line. Now, what's nice about rational exponents over radicals is that rational exponents can be added, subtracted, multiplied, and divided just like other exponents, and we don't have to worry about a whole bunch of radical rules that we'll never remember anyway. So, if you don't like doing math with fractions, you need to learn how to use the fraction keys on your calculator. I'm not going to get to show you that. If you have questions, you need to ask me during class or look it up in your manual. But again, don't get caught on test day not knowing how to use your calculator to your best advantage. You're allowed to use it, so learn how to use it. Alright, so here's a problem for us to work on. 5x to the 1/2 times 7x to the 3/4. So if these were whole numbers, we would add these without any hesitation, but because they're fractions, doesn't mean we treat them any different. We still have to add them together. So I'm going to be adding 1/2 plus 3/4. To do it by hand, I'd get common denominators. 2/4 plus 3/4 is 5/4. So when we multiply, 5 times 7 is 35. X to the 1/2 times x to the 3/4 is x to the 5/4, because when I add those exponents, that's what we get. Here's another one for us to look at. 32x to the 5/3 divided by 16x to the 3/4. So first I'll simplify 32 over 16, which is going to be 2. And then I'll subtract 5/3 minus 3/4. So if you do this by hand, you'll convert common denominators. 5/3 converts to 20/12. 3/4 converts to 9/12. So we have 20 minus 9 is 11/12. And so that becomes the exponent here. So again, when you look at this that you're supposed to subtract these exponents. Don't let the fact that they're fractions throw you off at all. If you don't like adding fractions by hand on paper, learn how to do it on your calculator, but you need to have some way of doing it where you can get it done quickly and not be intimidated just because they're fractions. Okay, one last example we're going to look at here. Okay, this says 25x to the 6th, y to the 4th, all raised to the 1/2 power. So remember, 1/2 power means square root. So we'll do the square root of everything in here. For the coefficient, it's easy. The square root of 25 is 5. for the exponents, it might not always be as easy, but remember you've got your power rule. So x to the 6 raised to the 1/2 would be x to the 6 times 1/2, or x to the 3rd, when we get it simplified. Y to the 4th raised to the 1/2 will be y to the 4 over 2, which of course 4 over 2 will reduce to 2. So we get 5x to the 3rd, y to the 2nd. Now I've got 3 more for you to try on your own. And if I were you, I would copy these, pause the video, and work them by yourself and make sure you understand. But now I'm going to walk you through them. So we've got to do, we're multiplying here, so we'll do 2 times 5 is 10. And then these are both in the top, so let's add 4/3 plus 8/3 is 12/3, but 12/3 simplifies to 4. So 4/3 plus 8/3 is 12/3, which simplifies to 4. We end up with 10x to the 4th. On part B, let's simplify. 20 divided by 5 is 4. And then let's divide x to the 4th divided by x to the 3/2. So of course we'll have to subtract 4 minus 3/2. Well, that's going to be 8/2 minus 3/2, which is 5/2. And here it is written out by hand. Okay, now on the last one, we got to do the square root of everything in the parentheses. So the square root of 36 is 6. The square root of x to the 10th would be x to the 10 over 2, or x to the 5th. The square root of y to the 6th would be y to the 6 over 2, or in other words, y to the 3rd. So we end up with 6, x to the 5th, y to the 3rd. So, turns out rational exponents can also be used to simplify radicals. And this is a good thing because radicals that have really high indexes can be kind of intimidating to look at and kind of clumsy to handle. So if you know how to simplify that index, it makes life nicer. And what we're going to do is switch from radical form into exponent form. Of course, you'll have a fractional exponent. You're going to reduce that fraction and then switch back into radical form if you still have a denominator on your exponent. Here are a few examples. We're going to simplify the 4th root of x squared. Well, if I go into exponent form, my top number is 2, my bottom number is 4. 2/4 simplifies to 1/2. In radical form, that is simply square root of x. Now, wouldn't you rather see that than this? So, of course, this is the nicer way to leave the answer. Okay, let's look at 3rd root of x to the 12th. Well, if you go into exponent form, you get 12 over 3. Of course, 12 over 3 reduces to a whole number, which is x to the 4th. And then I don't need a radical because I don't have any denominator on my exponent. So how am I going to put anything under a radical? Alright, x, or the cube root of x to the 6th gives us x to the 6/3, which reduces to x to the 2nd. And then the 8th root of x to the 10th becomes x to the 10 over 8. 10 over 8 reduces to 5 over 4. And if we go back to radical form, we're going to get the 4th root of x to the 5th.